time these days because I answer all my own email. And I travel to very few of these events, so it's just so super to be here. That video was outstanding. I never see what the rest of the world sees. You never see it when you're on the inside. I have a lot of current computer experience with Macintosh products and the like. Talk about that quite a bit. You know, watching the video, I mean, there's a lot of things I want to say about Steve Jobs, but it's probably going to wait until the answer and question period, because I'm going to give a talk today on that's kind of entertaining on the early history leading up to and through the early starts of Apple Computer, and then answering questions I can answer any period of time. But you know, watching even the Think Different video just made me remember how, you know, one thing Steve and I had so much more in common than anything else was a love of Bob Dylan. You know, what he stood for, how much more significant he was the Beatles. Well, where do you get some inspiration to go in a certain direction in life? Like, I'm kind of technical. There's a lot of things I can say about myself. I love gadgets, and probably a lot in here too, and computers are important to me. But when I was about 8 years old, we moved to a new house in Sunnyvale, and I discovered these books called Tom Swift Jr. books. Some of the kids would buy regular books on the Hardy Boys mysteries, and others would buy Nancy Drew. And I and a few of my friends loved Tom Swift Jr. He was an engineer, he was a designer, a scientist, an inventor. He had a company with his father. He could go into the laboratory and come out a few hours later with some contraption to go into outer space, or a submarine, or some plasma field to entrap alien presences that he detected with radios. And this was, well, we had a curfew, and I couldn't really leave my light on at night, but there was a street light right outside my window. And so there was one place in the corner of the room I could put the book down, lean over the bed, and read it late at night, and that's my favorite memories. And I would say just reading those books, boy, that was my hero. Read, you know, other book inspirations in early days. A book called SOS at Midnight talked about ham radio operators solving a kidnapping.
The last page of the book said, anyone of any age can write to this address and get information. You can be a ham radio operator. Well, how neat to be so young, to be in 5th grade, and be reading something that, wow, this real exotic, intelligent engineering type thing, you can do it. That was so neat, you know, like you can do it yourself. So by 6th grade, I had a ham radio license, soldered together ham radio. I was very lucky to have, you know, the father that I had for a lot of reasons, but he was an engineer. And he would teach me on a blackboard, show me how circuits worked and electrons flowed and how to do certain calculations and make the circuit right. And he would lead me in certain directions sometimes, but not really lead me, but he'd be there to help me when I was inspired in that way. And I had, in our neighborhood, Silicon Valley was called Santa Clara Valley back then, and it was full of fruit trees, one of the largest fruit-producing areas of the world, actually. And so our little neighborhood of houses, these beautiful new type of homes called Eichlers, that amazing architecture, middle class could live in there, and we'd have a little outpost of houses, but if you rode your bike north, south, east, or west, you were in orchards. You know, they'd build a brand new school because everything was new in Silicon Valley. I mean, it wasn't Silicon Valley yet. And you'd ride your bike through an orchard to get to this brand new school. A lot of parents were moving in to work for the company Lockheed. That was the big company in Sunnyvale. And my father worked for Lockheed as an engineer. And in doing that, he also had to build very tiny, lightweight parts for things like submarine missiles and guidance systems. Well, he was in close contact with the people of the early transistor companies in the area, Raytheon and other companies, and Fairchild. And so he was on the leading edge of transistors, miniaturization, and chips and all that. I kind of found out that I was a genius in 3rd grade because, well, my mom did some math flashcards with me one night, and when I went to school, the teacher pulled out some flashcards for us, and I was the only boy that could beat the girls. So I knew I was a genius. Well, it's funny though, you know, I started thinking that day, I thought, hey, I'm good at math. I've never thought I was good at anything before. And when you start thinking you're good at something, there's a self-fulfilling prophecy. You tend to perform better. That becomes more important to you to study, and you kind of become good in that area. So I had a real lucky accident. Got me started thinking I'm good at math, and I became good at math. My dad gave me a lot of influential discussions about how education was so important to my future and to the world, and that made young people important. Because he almost said it, the way I remember it being young, was the adults had a pretty messed up, screwed up world with wars and things like that, but we were going to school to study them all, study things and make them better and make the world better. And that really makes you feel good when you're a child, being told that, you know, your future is to do things better than we did it. One year I got a transistor radio in about maybe 6th grade, 5th or 6th grade, a little product from Japan, little blue radio, and for years I slept with the radio on next to my head on the bed all night long, listening to music. And I thought, wow, I went to my dad, and he was working with transistors in these military projects, and I said, wow, you know, look at these transistor radio. Isn't that cool that now they're making transistors so people can have small radios? And he said, well, that's not really why they're making transistors. They're making transistors for the military. And once they have it for the military, some of it kind of finds its way into products that we use in our own home, in our own lives, like transistor radios. And I was disappointed. And to this day, I always go back to that conversation and think, I remember in my head just an internal decision that I wanted someday for products to be made for people that live a life in a home, to have a better home. Science fairs in early school years were very important too. I got steered into, you know, like the other electronic kids. So we had a block full of a lot of parents that were engineers. New parents, a lot of young kids. We had a lot of kids in our neighborhood, and a lot of them liked electronics. Could buy parts at Sunnyvale Electronics and solder them together and make little oscillators and flashers and house-to-house intercoms. But in the science fairs, I stumbled into, and it was partly accidental, some nice little projects, you know. And by 5th grade, built a big, huge project with 92 lights and 92 switches for the electrons of an atom. And those switches had to be wired with some reasoning that every single switch turned on more and more lights, and the next one turned some of them off and turned others on because electron orbits change around. And I had to learn about diodes, a smart device, something that knew to send electricity one direction, but don't send it back the other way through the other lights. And that was sort of a first learning step. Most of learning goes step by step. If you know something really well and you try to teach a young kid that point, but it's above his cognitive development, step by step, they don't learn it. You have to go, as a teacher, you have to go in short, small, appropriate steps. And I was lucky. Okay, so I saw a diode and I learned one little element of electronics, one little part and how it worked. By 6th grade, I embarked on a huge project. My dad, because of his real good connections with the transistor companies, got hundreds of diodes and transistors given to us as cosmetic rejects from local companies. And we had a lot of those. And I learned about logic gates. I actually accidentally stumbled on a book that my dad had, or not a book, it's a journal for engineers. They didn't have magazines covering computers in electronics or anything back then. They had ham radio, they had electronics, but they didn't have computers. So only certain engineers would have these kind of journals, and I opened it up. A few of the articles I could understand, you know, articles on big, huge computers with vacuum tubes and thousands of them and how many calculations per second they could do, and other articles one was about a big, huge CRT, and the dots on the CRT were memory. They could be written and turned on, they could be read, and then they could be refreshed. And it was like the memory was a huge CRT display, like a TV set. What a fascinating article to read. And then when I was that young, about 8 years old maybe, and then I read an article about logic gates, something that can make a decision if two inputs are both ones, the output's a 1. Otherwise, the output's a 0. And learned about AND gates and OR gates and algebra that can switch one into the other, Boolean algebra, and I loved it. And you know what? As a 5th grader, you didn't need high-level math. You didn't need to know matrix multiplications and math analysis, and you didn't need to know any calculus. Anybody that kind of knew addition and counting could pretty much stumble and understand logic. It wasn't that hard. Why was it such an obscure thing that almost nobody in the world worked on this stuff? But I was so lucky to stumble onto it in this magazine, fall in love with this journal. Well, now tic-tac-toe is a game of logic. If certain squares are taken with X's, you know where to put your O. You can make a logical set of rules. And that fit this whole concept of logic gates. A logic gate could have inputs for square 1 and 2 and 5. And if they're all taken, then my move is going to be square 7. Real simple logic. So I pounded a bunch of nails into a 3x4 piece of plywood. Soldered transistors and diodes and resistors, building up gates and gates and more gates and gates, decision gates, and built a tic-tac-toe machine that was just huge and immense. Part of making these very large science fair projects is you've put yourself into building a long project that's not over in a day or two. So, and that's a real good thing to understand when you're trying to build something significant someday in electronics, to go through that step. Also, I was, way ahead of my time. I mean, computers weren't even in colleges at this point in time, around 1960. Now, in 8th grade, I took a science fair another step further. I took hundreds of these little transistors and put them on a little board, a little tighter, and made binary adder. Binary is the mathematics of computers. Switches can have 2 positions, 0 and 1, up and down. High voltage, low voltage. So I made 12 switches in a row, or 10 switches in a row. You could toggle in a number, like 100111100. It's a binary number, and it equals 89 in decimal. And you could toggle another number in, up, down, up, down, down, up, down, down. And that number is equal to 100 in decimal. And you add them together, and a bunch of lights come on. And you look at those lights, 1, 0, 0, 1, they're on or off. On or off, on or off. And the answer is 189 if you look in a chart or you do some figuring. Pretty slow and awkward, but isn't it neat that for the first time in history you could ever imagine building a device that can actually calculate like this? So I built this thing for a science fair, and it was so neat. I won all sorts of awards, got the first airplane trip of my life. The Air Force gave me the award for the top electronics project in the whole Bay Area Science Fair. And I was in 8th grade, and the science fair covered up through 12th grade. So I was one of those early starting electronic whizzes and geeks and all that. It was around that point in time, too, in junior high school, where kids start to socialize a lot. And pretty much, I kind of, dropped out of that sphere. I was sort of a math genius and a technical people, so they didn't talk to me as much as, normal people or in the same way. And I didn't know it. Now, I was on this little course working my way up the stairway to finding out what is a computer. Somehow I wanted to know what computers were, but I was way too shy to ask or to deliberately try to find something that described what is a computer. I wanted to stumble into answers on my own. So far, I had come across learning how diodes work to stop electricity going one way, how to put diodes and transistors together to make a gate, how to put a bunch of gates together to make an adder. I'd even figured out how to take an adder and subtractor and put in a few more gates of my own and make it one circuit that does both. I'd even solved some circuit problems that resistors didn't work there. You need diodes. And so I was working my way closer, but I still didn't know for sure what a computer was. I knew it was a magical word. In 9th grade, I went to a science fair, not with my own project, but just to go. And there was a project, and it had a bunch of switches that would select operations, like move a number into a certain set of storage registers, or add 2 storage registers together, or put those 2 storage registers in some other storage register. And it had a motor, stepping motor. And the motor would go chunk, and some lights would flash, and the first set of switches, that instruction would get executed, whatever they said to do. And then the motor would go dink, and number 2 would happen. Motor goes to 3, 4, 5, and every once in a while it could make a decision if the number was positive or negative, for example, and the motor would reverse and go back up to the top. So I learned, that was where I learned, a computer does one thing after another, after another, after another, in order. Okay, that is cool. So I can design some logic circuits that do one thing, and then they decide to do something else, and something else, and something else again. I was getting closer to, in my head, to what a computer was. And that whole period took years. So it was slow development. I was doing lots of other kid things, in the neighborhood. We had a lot of fun. We ran a house-to-house intercom once. We started, putting in microphones and buzzers and speakers, and we ran wires down to the end of the block to Bill Werner's house, and over the light poles, throwing it over like a bolo kind of. We got it across the street to Greg Angel's house, and we ran it all the way up the fence, stapling. I don't know how we got away with stapling these wires in. They worked into a fence, wooden fence, all the way up the block to Stephen Delatour's house and over to Bill Fernandez's house halfway up. And that was kind of a really neat project. I remember it meant so much to take ultimate care and draw the straightest lines I could with colored pencils and just draw such perfect diagrams of my designs and what they would look like and all that. So that was a big deal to us. Well, at one point, the house-to-house intercom stopped working. And so we walked along the fence, and there at one of the houses, this guy had cut the wire in about 20 places. And to kids, you just sort of think, it's a fence, I'm just running a wire on a fence, and you don't realize there's all sorts of properties, people own properties. So we redid the wire on the other side of the fence. So we learned about property rights a little, and another good experience. Just building your own little projects like that. House Intercom. I went out to the backyard once where the wire came in, and I went out and hooked up a speaker, and I was going to hook a Morse code key because I knew Morse code from being a ham radio operator, and so did my friend up the block had taken the same class. He wasn't a ham, but we were going to send Morse code to each other, and all of a sudden I heard him talking. I listened to the speaker real close, and he was talking. I said, "Hey, Steve, you hear me?" It's Stephen Delatour. And he's, "Hey, we can talk." What a surprise. A speaker can be a microphone. One of the neatest ways of learning is when you just learn it on your own and you don't have to read it in a book. So in junior high school, those of us that grow up electronic tend to like to play a lot of little pranks. First of all, we know this mystery of the world that people who don't know electronics don't know. And if something doesn't work, they don't know why, and it might be totally obvious to an electronics person. Or if something sparks a little or shocks you, we know what it's all about. Well, so we have all these energies in us, like normal people, to socialize, but sometimes we aren't the talkative ones. We're the quiet ones, real independent, quiet, studying our room, doing our own little things, only talking to our techie friends. And those energies have to come out. Those energies that don't have a way out in parties and making up little small talk and stories and learning how to talk like young kids do. And so the energies often come out as pranks, not trying to destroy things or hurt, but just trying to play tricks. I don't know why. Psychologists study this and say it happens. So sure, I played a lot of pranks in school. In junior high school, I got caught a lot. Got caught for a lot of things, and they didn't let you get away with anything. One time, we figured out that you could make a little hole in a pencil and take a paper clip in it and wrap a rubber band, and you put a spit wad on it and go, and it fires the spit wad, pop, and it hits the blackboard. The teacher doesn't know who did it because you didn't have to move your hand. You just let the spit wad shooter shoot it. We used to love those, and one of the guys in our class drafted out a neat drawing of a gun made out of metal or something. It had a firecracker at one end and a pin inside of it, and it'll shoot the pin. Pin gun. And this phrase has got going around the school that there were pin guns, and somehow I got associated with the pin gun that didn't exist. And one day I got called out of class, and the vice principal brought me into his office, and he had these 3 little devices on his desk, and he said, "Steve, we searched your locker and we found these pin guns there." I looked down and I told the vice principal, I said, "Those aren't pin guns, those are spit wad shooters." Up to it for a very long time in my life, that was one of the best lines I ever stumbled into. The truth is better than fiction very often. You can't make up some good stories. So in high school, I'd been caught so many times in junior high school. By the time we got to high school, I didn't get caught for pranks, period. I mean, usually they were just little electronic sound makers on a TV set, or go into driver training class with the simulators and make a siren in the middle. And one of my favorites was putting fake notices on a door that the class had been transferred to another classroom. Because sometimes the teachers fell for it. But one time I did get caught. But I got caught kind of because they lied, said my friend turned me in. His friend told him everything. But what happened was I went to a friend's locker, my friend Bill Werner, and I put a little electronic metronome in his locker. It's going tick, tick, tick. And I used a couple of battery canisters that looked a little vicious on it, But I was pretty advanced in electronics. So, and for some reason, by then I had done so many pranks and jokes that you couldn't just do a plain one. You had to do better than before. So I had a little switch that when he opened the locker, it just started ticking faster. And then the principal, I had to sit there. I had to sit at a table with the cops and a box with the wires out, and I'm thinking the bomb demolition squad came in. Oh no. And the vice principal and the dean and my counselor and everybody sitting around, and the principal described how he opened up the locker and clutched this thing to his chest and ran out to the football field and dismantled it. And I saw him tearing wires apart, and I just remembered when it sped up, the ticking, I just laughed, and I kind of had to cough to cover my laugh, but that one was worth getting caught for, to hear that story. Anyway, I started, one day I said, you know what, I want to start trying to make something closer to what a real computer is, out of chips. Because now, not out of chips, but out of gates. I don't even know if I knew about chips yet. But a gate is the smallest little element of a chip that can have some logic. And I knew how to build adders and things, but could I build some more complicated machine? I decided to build a machine that could do multiplication by doing add, and then shift and add and shift, add and shift, and sort of like the way we do addition as humans. And it was even going to be in base 10 arithmetic. And it will do square roots, because in school we learned how to do square roots. We had a method. Can I somehow make an electronic device that can do all this? And I sat down, and it was pages and pages and pages of gates and somehow little registers that would stop things and hold them up, and a signal would come, and they'd go to do the next step. And it was pretty good. I have no idea if it was ever good enough to work. It was a lousy design, but it was a first design, and it was a first attempt at designing a full computer. And I was starting to get proud that, hey man, I love designing computers. Funny thing is, I thought I knew what I was going to be in life. I told my dad in 6th grade, I'm going to be an engineer like you. But my second choice is to be a teacher, 5th grade teacher, like my 5th grade teacher, because she thought I was smart in science. She respected me. She made me feel good. So I started that early, wanting to be a teacher. I was going to be an engineer, but engineers design televisions. Engineers design radios. Engineers design satellite guidance systems. I had no idea that engineers design computers. I have no idea who does those things. They're so rare, and wherever they are, you never thought that you'd be doing that in life. Even by the time I graduated high school and was designing computers, I didn't think I'd ever do it as a job. I didn't think it was a thing you do as a job. Well, my electronics teacher saw that I kind of knew all the electronics. So much that if any other students asked me for help, you never know what the result might be. It might be working, and it might blow up their radio. One of my friends got a little bit in trouble. A teacher told him he had to write a report on electronic crystals. And he came to me. It was my friend Bill Werner. He wasn't that smart. He lived down the block. And he said, Steve, can you write it for me? He was my lab partner at the time. He said, can you write the report for me? And I said, oh yeah, I'll write it for you. I thought that was pretty cheesy, getting somebody else to write your own report. So I wrote a really good report out of the book. I researched it and wrote about XY axes and how the cuts of the crystal made at certain frequencies and how they were tested. And it was a good one-page report. But I wrote another totally farce report about crystal glassware and crystal gems and every other kind of crystal word, there was. And so I showed Bill the good report, and I said, I'll put it on his desk for you. You only get a certain number of chances in life for fun like that. My electronics teacher, though, said, hey, Steve, you know all this stuff, and you can teach the class, and you're president of the electronics club and all this. And I thought I could teach, but I know now that I couldn't teach back then. When you think you know something and you're bright like a student, you can't really teach and explain things so that others will understand. So he arranged for a local company to let me come down once a week and program a real computer. What? This is pretty unusual that a school didn't say, our school is the limit. We provide something within a certain framework, and you're going to have to find something beyond it yourself. This was a case where a teacher in the school found the outside assistance. For 1 or 2 kids, he would find engineers in companies that would let them come in and learn more. So I got to go down and program a real computer. I got a Fortran book and learned the language Fortran, and I wrote my first program. I went down, saw the computer and how the punch cards went in, and the keyboard could type the punch cards, and then there was a printer, and I wrote a program. And my first program was called the Knight's Tour in chess. It's where you start a knight out at 1 square on a chessboard, and he jumps like knight moves do in chess, and jumps to another square that's never been hit, tries to hit all 64 squares with knight moves without ever repeating a square twice. So you start jumping around and you find out, oh my gosh, he's stuck. Every move will hit a square he's been to. You have to backtrack and try a different angle and backtrack and try different moves and change them. So I wrote the program to do this, and I thought, you know what? Human beings have really slow minds. We can do about, one thing a second if we're lucky. And if you wanted to count numbers, you can't count a number a second. How are you going to say 975,656 in 1 second? You're just never going to even count at one thing a second. This computer could operate 1 million operations a second. This was an out-of-the-world number in 1967, actually. This was just out of the world. 1 million things a second. What power. And I wrote this program that would just go through the steps and back up and go through, and it would find an answer. But it sat there, and the lights flashed, and nothing came out of the computer. They told me that I had a loop. A loop is when a program just keeps going around and around and doesn't really get anywhere. So I went home, rewrote the program a little, came back the next week, and I had it print out chessboards as it went. And I looked at it, and it was working perfectly. It didn't have a loop at all. But when I let the program fly, it didn't come up with an answer. And then I studied it, and I did some calculations, figured out it was going to find an answer in 10 to the 25th years. A lot longer than the universe. So, I didn't really make a mental note of it at that time, but when I look back on it now, it should have told me that problems like that, which have known solutions, obviously have smarter people that think out approaches to solve things. Algorithms, proper methods are much more important than raw speed of a computer. Well, I was down at Sylvania one day, and I saw a little booklet called the Small Computer Handbook, and the engineer saw that I was interested and said, you can have it. And now I had a key. I had a book in my hand that described about maybe 50 or so instructions, different little instructions that computer could hold and do. Tiny instructions like load the register from memory location, whatever. Store the register in memory location. Add the register to memory location. It could do a few very simple things. Test the memory location. Branch to a different address. These kind of little things. Very small steps, but it had about 50 of them. Now, that was the first time in my life I knew what a full computer had. I had my knowledge of gates, and around that time I got some chip books. So what did I do? I sat down on my own. Didn't have a class, didn't have any friends doing it with me, my father wasn't even doing this, he didn't really do computers. And I sat down on my own and just said, on paper, can I put logic gates together in a way that will do what those instructions do on this computer? And I started working on a design, and I designed a PDP-8, the most of it. I didn't do all the I/O and they had core memories. I don't know if you remember core memories, tiny little slits of wires in three directions, all crisscrossing on little tiny cores that were magnetic material. That was what memory was. Big, huge plane of it. Might even be 4 kbytes on a big, huge plane of these tiny little magnetic cores. They're gone now because of RAMs, but that was the memory taught back then. Well, I designed my version of this computer. And then, I got bored a few weeks later, and I thought, maybe I'll try designing it again. Maybe I'll come up with some better design. And I went through a second time, and my design was better. And then my dad gave me some new chip catalogs. And there were better chips out. There was a chip now that had 2 full adders on one chip instead of just 1 adder on a chip. There was a chip that had 4 gates instead of just 2. Wow, I sat down and I found out that I could design it in fewer chips, partly because chips were getting better, partly because I was designing better. I got so interested in this that I started going down to, I wanted to get more manuals on more computers, because there were about 20 different mini computers introduced. The mini computers looked like the Altair in the video. A rectangular faceplate with a bunch of switches that you could toggle in binary numbers. 10011101. Push a button and it goes into some register. Click, 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 push it, it goes into memory. Push a button, it goes into memory. Kind of slow, but it's a computer and it has all these little flashing lights. And that's what all the mini computers were. They don't look like they belong in a home, no. They look like they belong in commercial environments and factories and things, on racks and things like that. Well, I didn't know how to get manuals from the companies. I didn't know where the companies were, but there's this place called Stanford Linear Accelerator Center nearby, and there are a lot of really bright people that work there. And if you drive up on a Sunday or something when nobody's around, one thing about bright people is they always leave doors open. True story. We'd try a few doors and we'd always find a door open to the building that we found had the library in. And it was great. We could wander around and look at things, and they had a big, huge IBM 360 Model 90 computer, one of the biggest in the world, and we could walk around it, and nobody was around, knew we were there. Lots of doors open at a place like that. So we went into the library occasionally. I went in, and then usually with my friend Alan Baum, a high school friend, and we would find the computer magazines and go to the back page, and you could order manuals for computers, for mini computers. I'd order the manual. So I got a manual for a Varian computer, and then I designed it out of the best chips that were around. And then I got a manual for a Hewlett-Packard computer and designed it, and another company's computer. And I started designing these computers, and I was so bored, every few weeks I'd want to sit down and spare time and design a computer better than I had done before. My goal was all intrinsic in my own head, because nobody could grade me. Nobody knew, Steve did a great job. Steve did it better than he did a few months ago. Nobody gave me credit. Nobody gave me money. Nobody gave me a title. Nobody gave me fancy clothes. It was just for fun. You just do what you want to do. It's your pastime. Well, I sat down, and my goal started becoming design it with the fewest chips I can. Eventually, I started getting so good later in life that I started saying, design it as good as any human being could possibly do. Because by then, I was searching for tricks with chips. Tricks that no other human being would search for and look for. Use a chip that's designed to be a shift register to replace a bunch of logic gates instead, because it just happens to put the right signals out if you'd use it a certain way. And hard to explain things that have no definition in any books, but my goal was to come up with the fewest chips I'd ever done before. I was competing with whoever was best in the world. I was competing with myself too. What was the best? I got to beat myself in the past. And the newer chips came out. I always had to be familiar with them and up to date. It was a lot of fun, and that was in high school and the first year of college. Around that time, this was all real independent. I'd go into my room at my parents' home, and I would just study. Or when I was in college, I'd go in the dorm and just sit down on paper, all alone, nobody around. So nobody knew I did this. I didn't share it with friends or anything. My math teacher heard a rumor in high school that I knew computers. Okay, I don't know where he heard this even. I would sit in his class designing computers, but how would he ever know? And he said, hey Steve, the math department has this little computer project down the hall. And why don't you go down some days, and you're smart in math, so why don't you just go down and program, put the computer together, do it. So I went down, and one day I went through all these it was one of these little things with a bunch of switches and dials and a couple relays, and it was kind of nothing for me. It was a real simple, low-level nothing. I went through it all in one day, but this was the fourth period class, so sometimes I would just get out of fourth period class to go down and program and work on the computer, not program, but work on this thing that they thought was a computer. But it was really just a little kit of switches. And what I would do is instead, fourth period was the lunch period of our high school. And we had 3 different lunch periods through fourth period. So I would simply go out and take all 3 lunches and see all my friends. And the math teacher never knew it till this year when I finally told him. Well, came time your college was approaching, your senior year of high school, and I had in the SATs I got all 800s on mathematics and science SATs, except the 770 in chemistry. And I could have looked for really prestigious scientific schools or something, or technical schools, but I didn't really have that pressure from my parents that you have to go to a particular school or have a certain kind of life. And I was really glad. They just kind of helped me when I needed help, but didn't really push me in a direction, and I didn't feel that way. Well, I went with a friend, first trip ever out of California, went to Colorado, Boulder, Colorado, on Thanksgiving. We woke up the next morning, and it had snowed. I had never been in snow in my life. There are important things in life like snow And there are other things in life that are fun, like computers and mathematics and science and grades. And I didn't apply to any other colleges. That was it for me. That was the only place I was going. It was a fun year at the University of Colorado. Computers in college. Maybe there were a few colleges in the country that actually had undergraduate computer programs. I couldn't tell you which ones. So any computer classes at the University of Colorado in 1968 were graduate courses. But even since I was a freshman in engineering, I was allowed to sign up and take them. And it was great. So I took my first computer course on Fortran programming, and I learned a lot. And a really good teacher, really good class. And I got an A+. But I started saying, wow, now that I'm allowed to program a computer because I'm a student in a computer class, I'm going to write all the programs I want to write. Well, what kind of programs do you do? I didn't know anything about, how would a student, freshman in college, know anything back then about databases or software that runs companies or decisions? Well, what kind of programs do computers run for the military? I don't know. But I had handbook of chemistry and physics, full of mathematical tables of different kinds of numbers. And I said, I'll just write it to a program that prints powers of 2, getting bigger and bigger and bigger. Inverse powers of 2, getting smaller and smaller and smaller. And I'll write a program that prints Fibonacci numbers and all these different things. So I wrote 7 different programs, arranged each one to print 60 pages and stop before the computer kicked it off after 64 seconds, 60 pages, and punch out the cards that I could shuffle in so it would print the next 60 pages the next time through, and the next 60 pages the time after that. So 3 times a day I could run programs through on punch cards on the computer at the University of Colorado. 3 times a day, 7 programs, 60 pages each, multiply it, reams of output piling up in my dorm room. Numbers were getting larger than a page, larger than 2 pages, incredibly large numbers. Who knows what it's worth? I don't know. To me, it was worth the fact that I had done it, and it was neat. Well, they called me in, and the professor was very upset, and he acted like I was some kind of radical out to get him. And I was the shyest little guy, afraid to talk or anything. But I guess he'd been threatened by the SDS back in the Vietnam days. And he sat down, turned on a tape recorder like this was police stuff. And he started asking me why I wrote these programs. I said, it's Fortran, it's a Fortran class. And he said, it's not the Fortran we teach. And he was very upset about it. And then he called the computer department and told them they should bill me. And I was so scared that I was going to get a bill and no money to pay it, no way to pay it back. So I didn't tell my parents. I didn't try to go back to that school. And I didn't realize, now looking back, it's very obvious to me that as a student you didn't get to use the computer, but the class had a budget of computer time. And I ran the class 5 times over its budget. And they rented it from their department, that rented it from the computer department building. So there's a whole big accounting trail that as a student you would never think of. As a young person you wouldn't think of it. And I had somehow run him over his money, and he was simply getting out of paying it. They wouldn't have charged me. I realize that now. But I was scared then. That was a fun year. Electronics lets you do little mysterious things. So I built a little tiny transmitter, and it would transmit and jam a TV set that was nearby and just mess up the picture a little. So I could go into a store somewhere and watch, an elderly couple being shown a TV set, and the picture would go a little bad. So the salesman would reach to the fine tuning and tune it, the knob a little, and it would go perfect. And he'd pull his hand back and it goes bad. And I got really good at doing this and watching like I was an interested customer. Well, we didn't have too many color TVs in the dorms, so most of the people would all go over to this one girls' dorm that year. Down in the basement, they had a color TV to watch at night. So we'd go over there and watch TV, and I sat in the back row with my little TV jammer and a 9-volt battery in my hand. And at some point, when it looked like nobody would catch me, I tuned it up, and the TV got messed up just a little, fuzzed up a little, a picture of the TV. And a friend of mine, this is just lucky circumstance, that knows that I have TV jammers, was in the front row, and he went and hit the TV. And I made it go perfect. Okay, this is psychology 501. And then it got jammed again, and it hit the TV, and eventually he could always get it fixed by enough pounding, and then eventually somebody else would do it. So for about the next 2 weeks, every night, one person would station in a chair next to the TV, watching the TV sideways, and whenever the TV got messed up, he had to hit it and tune it until it finally worked. Well, one time, there were about 3 people trying to fix the TV. I wasn't giving up easy that night. And I noticed that one of the guys had a hand on the middle of the TV screen and a foot up in the air on a chair. So I made the TV go perfect. True story. And someday I'm going to tell this story, and the guy is going to say, "Oh man, that was me. You did that?" They never once imagined that a person in the audience was doing this to them. When he moved his hand from the TV set, I made it go bad, and one of the persons yelled, "Freeze! Where were your bodies?" Because by now they knew that your bodies mattered. And he finally put his hand back. When he put his hand back on, it worked. And when he pulled his hand away, it didn't work anymore. And he put his hand there, and then he put his foot down off the chair onto the floor, and the TV went bad, and he put his foot back up, and it went good. And he turned around to face the audience, and he said, "It's a grounding effect." So for you ham radio operators, that makes sense to you. Another time, same room. Another guy said, "Hey, the repairman came and said it's the antenna." So they held the twin lead antenna up in the air. And I made the TV go good. And they put it down, TV's bad. So they held it up for a while. After a while, they had to, stand up on a chair to make it work. By the end of the night, I got this one guy that when he went up on his tiptoes, it worked. And down on his heels, it wouldn't work. And they never once suspected a human being was controlling it. The TV jammer was so much fun. By then I really liked small things my whole life. Tiny things like a tiny transistor radio. So I built one super tiny and concealed with a battery inside of a magic marker pen. And my computer class that I described was taught to a few older students, more higher division students, live in one room. But we were such a large class that the rest of us had to watch it on 4 TV sets in another room. Actually, we were not a large computer class, but the rooms were real tiny there in the new engineering building. So 4 of us were watching it on TV screens, and I turned on my little magic marker jammer, and I didn't know what would happen to closed circuit TVs. They didn't have an antenna really, and one of them over on the far right got messed up the worst, and some of them barely got touched. The one right next to me hardly got messed up at all. Instantly, what a surprise. I was just going to jam it a little and then unjam it, right? Instantly, 3 older-looking guys stood up in the front of class and looked us over, and we were a lot smaller than this group, much smaller. Looking us over, saying, "Okay, who's got the transmitter? Turn it off." And right, 3 guys looking at us, I'm going to reach over and turn something off? Right. And now they kept watching us through the class, and I was scared to do anything. I wouldn't touch that device because the guy next to me might even see that I was turning it off. I was scared. I said, "I'll just walk out with everyone else. They'll never know who had it." And near the end of class, one guy decided to leave early, and he was sitting over on the far right, underneath the TV that was jammed the worst. He gathered his books together. I looked over and saw him gathering his books. He got up to walk towards the door. As he walked towards the door, I kind of made the TVs flutter in and out. And then when he left the room, the TVs went perfect. And a TA, one of those 3 TAs in the front of class that I didn't know would be there, pointed at him. And later on, a friend said, the TA said, "There he goes." So I learned a real good lesson. If you make it look like someone else did it, you get 2 for 1. There is a good prank and there is an excellent prank. So add that little touch. That was to come into play the day we introduced the Apple II, strangely enough. A prank that's not that well known. Well, I did come back. The next year, I didn't try to go to Colorado again. I was just too afraid to tell my parents that they were going to bill me for computer time. So I went to the local community college in Cupertino, De Anza, and they had a computer there, an IBM 360, so that was the big part of my life. I would take extra courses on it that didn't even count towards my college degree, weren't even transferable to Berkeley, where I was going to go next. And a friend of mine from high school, Larry Platzik, worked in the computer center at the college. And he didn't really program computers, but he knew how to turn everything on in the right order. Turn on the disk drives over there, and turn on the printer over there, and turn on the big computer, and with all the lights are flashing, he knew what to type to get it to start correctly. So, well, he had sneaked a key, a copy of the key. We would go at midnight and open up the computing center and go in. He would turn on all the equipment, and we would put a piece of typing paper in the main terminal so that it would type what it was doing but not leave a record for the school. And then I'd sit there and I'd run punch cards through thousands of them and go through listings and then write other programs that took my punch cards and punch new ones and then run those through and got the programs twiddled and modified, and it was a real fun time. And we only got caught once. And it was a way that we kind of got out of it. Or they didn't know that we had a key. So that was fun. And that same year, Data General introduced a new computer called the Nova. Well, when a new company starts up, they would come out with a slick brochure introducing the company. I was a young kid, so I thought they're introducing a product. I'm sorry, I didn't know there were financial people that they're introducing companies to, but you open up the brochure, a description of the CEO, turn the page, a description of the head of marketing, a description of the head of engineering, and all this stuff. On the very last page of that brochure, you saw something that you wouldn't see nowadays. You saw a description in binary of the instruction set of that computer. And it was very strange. This computer, instead of having 50 instructions like a PDP-8, had one instruction. They took 16 bits of binary data and broke it into chunks. A chunk of 2 bits meant one thing, a chunk of 2 more bits meant another thing, which register, a chunk of 3 bits meant which operation to do, another chunk meant whether to set a carry, another chunk meant whether to do a test, and it was like little individual chunk pieces. Strange. It could do most of the operations of the other computers. It could do a few other unusual ones that might or might not have some value. And it couldn't do a few instructions it would have to do by 2 in a row or something. Strange. Didn't know what to think about this totally radical design in computers. Every other computer I had designed, and I designed a lot of mini computers that were around, all of them had about 50 instructions, and this one had 1 for arithmetic. Interesting. I set it aside for a little while. The company had some neat brochure advertising when you ordered their computer manual. Came with a poster for your wall. A poster showing this computer with its square rectangular face and the switches for binary 0, 1, 0, 1, and all the lights, and it would mount in a rack, and you put that poster on your wall. They had a second poster. The second version of the poster that you might get by accident was the one that showed it on like a dining room table. They had a flat sculpted version, kind of huge, but sort of in the shape of, something, I don't know, hard to describe what it is, something like an Apple II actually. Had a bunch of little switches, 0s and 1s, and binary lights and all. But it was kind of interesting because you had never before seen a computer portrayed in anything except a rack of commercial equipment. So that was a big memory. Kept those posters on our walls. I did, and my friend Alan Baum, who was the only other high school kid I knew that liked to do computers. Matter of fact, he went off to MIT, and he would send me photocopies of his books on computers. So I learned a lot that way, just getting them in the mail. Well, after that year, or during that year while I was going to De Anza Community College, I accidentally walked into a company that I thought sold the Nova. I told my dad, I'm going to own a 4K Nova someday. A 4K computer was enough to run a programming language. I'm going to own it someday. And he said, Steve, it costs like as much as a house. And it took me about 5 seconds, and I said, I'm going to live in an apartment. Made up my mind that day what was more important to me. Well, I walked into a company in Sunnyvale that was supposedly selling this product, but I walked in the wrong door, and here was a company with a big glass enclosure with a big medium-sized computer that they were building. They were going into business with a computer. I had walked into a computer company. Oh my gosh, do you have any jobs? Yeah, fill out an application. So Alan Baum and we filled out our applications, and we both got jobs for the summer as programmers. Wow, how amazing to be around this piece of equipment. They had a great computer, disk drives, and they had an operating system and lots of programming languages and software written to do all sorts of business things. And it was so great. I would go in late at night and run a program through to calculate E to 300,000 places. And the president's son saw me there one night, and I told him what I was doing, and he looked at me like, why are you doing these bad things? Like it was bad. You know, and learning is good. So figuring out how to do things is good. The company went bankrupt. It was a recession. The company went into, it was a great computer, but the country went into a recession. And I always thought that if you start a company and you make a great product, you sell it and you make profits. You make a lot of money. I never knew that you could have a good product and then just go out of business, not be able to sell it. I mean, they sold a few, but so that was sort of hard to deal with in my head. I went on unemployment for a little while. And while I was working at that company, I told one of the executives how I designed all these computers in my life, even though I was a programmer there. I said I designed them all, but I could never afford the parts, so I could never build one. And he said, hey, I'll get you some parts, because he had contacts with silicon companies. Wow, so I showed him a design of mine, and he ordered all the parts I wanted, and I got them. I got these adder chips, and I got register chips. I even got 8 memory chips with 256 bits of memory each. So I had 256 bytes of memory. And put them all together, and I went to my friend Bill Fernandez's house about 3 houses down on our block, and we worked there for about a couple weeks, you know, just after school, and we'd solder it together. And we soldered together this computer of my design. And we'd drink cream soda. And when we ran out, we'd run down to Safeway and buy more cream soda, and we called it the cream soda computer. Well, and it worked, and we even got to show it off to the press. And it even burned out while showing it to the press. That's okay. So we stepped on a wire and hit all the chips with 35 volts, and I don't have to tell you what that does. While we were building this computer, Bill said, hey, there's this guy that you should meet that went to our high school. He didn't go the same year I did. And his name is Steve Jobs, and he likes electronics, and he likes pranks. So you guys should get together. So Steve came over, and we started talking. We hit it off. We were, best friends for a long time. And we had a lot in common. Most of all, I'd say it was, really appreciating Bob Dylan's writings, because the songs meant something. That was important to us. After that year off, that I took off programming, I entered Berkeley and had a great year there. A lot of good computer courses. The all-time ever record that I've ever heard of a schedule. I had 4 graduate computer courses that were perfect for me, all of them in the same room. All of them on Mondays and Wednesdays, I'd go to one of the classes and stay in the same seat of the same room for the next class right after it. And on Tuesdays and Thursdays, I'd go to the 3rd class, immediately followed by the 4th class, and I never had to change seats for any of the classes. I all had the same seat in the same room, and none of my classes started before noon. So I boast about that. That was too good. While there, I heard a story just before going. I read an article called Fiction in Esquire magazine. And as I called Steve Jobs up halfway through the article and started reading these amazing stories of technical people that were outsmarting the phone company and setting up networks around them and driving around in a hidden secret group. And I said, there's something wrong, Steve. They gave all sorts of details, like a 1 is 700 hertz and 900 hertz. And to seize a phone line, you put 2600 hertz on the line, certain tones. And I said, fiction doesn't do that. Fiction doesn't give you details that are checkable. There's something really weird. And this article said that the phone books that described how to do this weird device called a blue box that could make free calls all over the world and bounce around satellites and control things and take over the network, all the books describing it had been pulled from libraries. So I said, Steve, there's something wrong. This article is like it's real. So we went down to Stanford Linear Accelerator Center the next day, Sunday, because they'd have an open door somewhere. And we pulled out, we found we went through books and books and books looking for any confirmation of what we wanted. Finally, I had a blue CCITT book in my hands, and in there I found the chart, and the frequencies in the article exactly matched the numbers in the chart, and it had the full list. And we looked at each other, and we were just stunned. This article that said fiction was really totally true. To this day, it's been found out that the article was 100% totally true. All the people in it were real, everything they did, everything the guy talked about, but it was so unbelievable, it had to be called fiction to sell it to a magazine. And we managed to build our own blue box, and we found Captain Crunch was the main phone freak of the country. He discovered that the Captain Crunch toy whistle in Captain Crunch cereal, if you blew it into a phone, it had just the right tone to seize the phone line and put it at your command. One blind kid, Joe Ingressia Jr., could whistle that tone and seize the line. And he could also, there were some systems in the country where with that just one tone, 2600 hertz, you could dial phone calls. Go, and that's a 3. That's a 3. That's a 5. So he could whistle calls. And he actually did a demo on TV once, and I taped it, and then I went back and counted the digits he was dialing, and because the phone next to him rang on TV, I counted the number of digits he dialed, and sure enough, it was his real phone number, which was known to phone freaks. Well, this guy, Captain Crunch, was the main one. Of course, he did everything in the world and drove around with a van and coordinated all these things, and his van was packed with equipment that could take over the phone company. It was better equipment than the phone company because he was a smarter engineer than they were. And we found out he was local. And a friend, dropped on me the fact that he worked at a radio station in Cupertino once. And we called the station, and as soon as we asked them about him by name, they said he dropped out of sight right after the Esquire article. We knew we had the right guy. 10 minutes later, the phone rang at Steve's house, and he arranged to come up to the dorm at Berkeley and meet us. I had been telling all these wild stories about what phone freaks did. They were in a lot of newspapers that year, 1971. I had been telling stories around the dorm and how incredible it was and what you could do with this technology and how tones worked on the phone system and all this. And Captain Crunch was the hero, and I kept describing him as this incredible guy that had this prowess with girls and everything. And now he was coming to my dorm. It was like the top celebrity in the world's coming to your dorm. And I was nervous, and we're just waiting, knowing he's going to show up, tonight. And everybody down the hall is probably looking to see Captain Crunch when he comes. And there was a knock on the door. And I went to answer the door, and my roommate stayed around that night and opened up the door. And here's this guy, looks really awful and disheveled and smelling like he hasn't bathed in ages, and he's missing a bunch of teeth. And I said, "Are you?" He says, "I am he, Captain Crunch." But we actually met him before the FBI did. He taught us a lot of phone freaking codes, how to get to different operators in different countries, and taught us a lot of this stuff. And he said, "I got to go out to my van and get my automatic box now." And I said, "Oh, can I go out with you?" I wanted to see all this equipment that controlled the phone network. And he looked at me and he said, "Yeah, like why?" And I started thinking something's wrong with what I thought he was, and he's acting like there's nothing in his van. Went out to his van, it was empty, except for a little antenna on the floor, because he would drive it around broadcasting San Jose Free Radio. So I started learning that all these impressions I had of him being super sophisticated and intelligent and great engineer and real ethical and just trying to help Ma Bell solve its problems really weren't. I had really not read the article right. Well, that night, after a late night in a pizza parlor with Captain Crunch, Steve Jobs and I had to drive home for an hour to Steve's house, where my car was parked, my Pinto, and I would drive it back to Berkeley for school the next day. So as we're driving home, Steve's car broke down. And we went to a payphone, and we were nervous. We thought we'll call Captain Crunch for a ride, but we'll call him with the blue box, but we don't know how to use blue boxes on payphones for sure. We had a little bit of advice, trick you have to do. So we got the operator going, and we kind of tried it, and she came on the line in the middle of the call, and Steve hung up the phone. And we tried it again, saying it's a data call or something. She came on the line in the middle of the call, and we got all scared, so we put money in. Now the cops showed up. Oh boy. And Steve's hand was shaking, but the cops, we were really long-haired then, the cops thought we had drugs or something, so they started looking with the flashlight in the bushes. Steve managed to get me the blue box, and I got it in my pocket. And then a cop frisked us, and he pulled the blue box out of my pocket. And he said, "What is this?" And I said, "It's an electronic music synthesizer. You push the buttons, 1, 2, 3, beep, 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 beep. It makes music." "Ah, what's the orange button for?" Steve Jobs said, "That's for calibration." That was the one that seizes the phone line. And a second cop comes and he takes the blue box. And we know that the operator's called the cops. And the cop says, well, what is it? I said, it's an electronic music synthesizer. And Steve Jobs says, the orange button's for calibration. Cop says, where's the computer plug-in? Steve says, it's inside. You know, ridiculous BS. We knew we were caught. So the cops put us in the back seat of their car, and they held the blue box in the front seat. And they started driving us out to our broken down car. The cop turned around, handed me the blue box, and said, a guy named Moog beat you to it. You can't make up stories better than the truth. And Steve even BS'd him then and said, oh, he sent us the schematics. After that night, we finally got home with a ride, and I got my Pinto and I drove it back to Berkeley, and at 3 in the morning, I found out that you can fall asleep on a freeway, and I totaled my car and walked into the dorm finally and told my roommate, good thing I didn't pay the $25 parking for this quarter. So I lost my car. After that year of college, I decided I wanted to work another year to earn money for another year with a car in school. Because when you're in college with a car, it's great. On weekends, you know, you're driving everybody, 7 people in a Pinto down to Taft and Rosemead and Tijuana. And, you know, we'd always go to Tijuana and get firecrackers. I had a good place to hide them that was real hidden, and the dogs couldn't sniff that. And so cool. Well, I decided to get a job, and I got it. It's easy. If you know electronics, never in my life did I go through a thing that a lot of people in college do, which is they say, well, I'm about to graduate. What will I do? Well, when you have a lot of electronics back to high school, it's like a vocation. You just get a job. There's lots of electronics jobs. You know electronics. You do it. So I got a job as a technician for a company where I got to test products out they were making, test all the chips and find the problems and replace them with good chips and fix things. And it was just the favorite job of my life, a small company, smaller than the number of people in this room, and got to talk to everybody and lots of friends. But after 6 months, okay, I had bought Hewlett-Packard came out with the first scientific calculator of all time. The first calculator that could calculate sine and log and cosine and arctangents and things and square roots. And it was amazing because I was a slide rule whiz all my life in schools. I was just the fastest and could go back and forth and do things in ways other people didn't. And now I had a calculator that could do everything to 10 digits accuracy perfectly, and it was just so tiny and small. Wow, it was the most important possession I owned. Cost me $400, which is like $2,000 today. And probably paid for it with Blue Box money because, well, I had this Blue Box design, a real clever design. I did a trick in there that I've never done that good a trick in any other design in my life, but I can't describe it that easily or this quickly. And Steve Jobs said, hey, why don't we sell them? You know, so when I had a design, he said, let's sell it. So we sold Blue Boxes and got some money. And I don't want to, there's some part of that I don't want to say on camera. No, it would embarrass Steve. A very unknown thing. It has to be private. Okay, so we sold them and we got money, and I got my calculator. And my friend Alan Baum was an intern at Hewlett-Packard, and he told the guys in the calculator division how good a designer I was at things. You're just self-taught on my own. And so they called me over and I interviewed, and they hired me as an engineer designing calculators, the product that I loved the most in the world. Like for you, it might be your Macintosh. I got to work at the company actually designing that product, the Hewlett-Packard calculators. What an amazing thing, and I didn't even have a college degree. I could design, so I could do engineering, so I was an engineer. That was just really great and lucky. A bunch of the engineers like to have a lot of fun things going on the side because their work is so intense, and the actual calculating and designing and getting things right and fixing problems all day work. So for relief, we had a lot of pilots among the engineers. So we'd take 4 pilots and 12 other people would get in their planes and fly off somewhere for lunch and fly back. It's a fun thing to do. First small plane flight of my life, Myron Tuttle was the pilot. When he came back into San Jose, he hit and bounced way up, and he came down, there's scraping sound. And he took the whole runway at San Jose to land this little 4-seater plane. And 3 of us had never been in a plane before, small plane ever in our lives, and we were silent, like just struck, and we couldn't say a word throughout the whole took him a few minutes and taxiing back around and coming back and parking, and we're getting out. We haven't said a word, and I thought, this is bad for a guy that you work with. You have to loosen it up and say something to him so he knows you're still friends. And hey, it's, things happen. So I look around for some little small talk to make, and I always look for something technical, some comment like, wow, that's that's a pretty big tire. Well, what I said was, that's neat how the propeller is bent. Is that for aerodynamic reasons? And he said it isn't. He bent his propeller. So we took the propeller and hung it up in our lab at Hewlett-Packard for the next couple of years. Myron lost his license right there. We all survived that one. While I was at Hewlett-Packard, I managed to get my friend Bill Fernandes, the same person that introduced me to Steve Jobs, in as a technician in our group. So he was our technician. It was great working with him. TI came out with a calculator around that time. Hewlett-Packard calculators were reverse Polish notation. Computer programmers, people who write computer languages, know that this is scientific. It's like decimal system or something. You put numbers into a stack. If you want to add 4 and 5, 4, enter onto a stack. 5, enter onto a stack, plus adds them together. Weird. It does the nouns first and the verbs last. And it's called reverse Polish notation. And it's used in computer languages to actually make things execute in the right order and unravel all the parentheses that a human being might write down. So our calculators were so sophisticated that my friend Ken someone, made a card with a huge equation on it. Huge equation with lots of things above the divide line, a lot of things below the divide lines, and square roots of huge functions and squares of little things, subtractions in the middle. And you could work it out on a Hewlett-Packard calculator. You could solve that big equation in your hand, pushing things onto the stack and doing it. It usually took me about 3 tries, and I would get the right answer. So I could do it with my Hewlett-Packard calculator. Now, Texas Instruments is going to introduce an arithmetic calculator that uses parentheses. Hey, that's not scientific. That's not computer scientist. What a joke. It was a toy. That's what we thought. So here came this calculator. We finally got it one day, the first one, and we were laughing about, what a joke. Look at these parentheses buttons, It's for little children in school. And then we kind of looked at it, and somebody pulled out the card with the magnificent equation on. And we all laughed. Let's see somebody solve that one. So I said, hey, I'll try. I was the guinea pig. And I took the Texas Instruments calculator, and I looked at the problem, and like with my Hewlett-Packard calculator, I started looking for which part should I do first, and what order do I push buttons on this new system. And I couldn't come up with an answer. No matter what I did, I was going to do it wrong and get the order wrong. And my brain wasn't big enough to solve that. And then suddenly I threw things out. I did the right thing. I said, if I can't solve it by knowing how to, forget that I know it. That was the thing that very few people can do. You have to wipe your head clean and pretend you don't know something. What does it look like to another person who knows nothing? What makes sense? And I said, I'll go from left to right. I'm just going to type this equation from left to right. It's the only thing I can possibly do. Otherwise, I can't type anything because I can't get an answer. I went from left to right, pushing the buttons as fast as I could, even risking I'd get a digit wrong. I went so fast and got the answer right the first time. I had to make one guess as to whether square root was first or second, before or after its parameter. I got the right answer, and I realized something here made sense. You simply write it, and you enter it the way we've written it through centuries of development of mathematics writing, and it just works that way. And it's the same system. And on a Hewlett-Packard calculator, you have to think. You have to remember where you're storing things on a stack and what's where. You have to think it out, and why should your brain think? Isn't it the purpose of electronics to build devices that save us from thinking and do things for us? Yeah, they're supposed to help us. So I tried to tell the other engineers, just type it in from left to right. Not one other engineer in Hewlett-Packard around me could sit there. About 7 of them tried. They couldn't go from left to right. Their heads wouldn't free up and say, they kept thinking, I have to do it in the order that makes sense by the parentheses here. So that was a good talent that I had. Also a good learning experience about people, kind of hard to give up what you're really used to and skilled at. Well, I did a lot of side projects while I worked at Hewlett-Packard, designed calculators in the daytime, came home at night, and I got involved with a bunch of people that heard about me, and I would design projects that were all kind of people-oriented things. Did an early pinball game for homes, did one of the first hotel movie systems, got involved with the first VCRs, company called Cartravision, an American company, before Sony had Betamax. Big Cartravision, they built about 8,000, they went bankrupt, and we could go down and buy color VCRs with a timer for $60 as engineers. No case, just an empty, but it was a VCR and it was color. You had to pay $1,000 for a black and white VCR back then. So this was just an amazing thing to learn about VCRs and how they work, and more about color and video and how it's stored on tape. I saw Pong in a bowling alley. And I said, hey, I know logic design and I know electronics of televisions. I'll use my home TV, snake a wire in, attached to the right points on the transistors, because TVs didn't have video in back then. And I built myself a Pong. And when you missed the ball, it would say, darn, or something worse. Or it would say, oh, you know what. 4-letter words only. And so I built this little Pong, and Steve Jobs got a job at Atari, and they called me in and saw they liked my Pong that it was only 20 chips, because they liked real tight designs that didn't take many parts. And they tried to hire me, but I said, Hewlett-Packard is the company I've loved my whole life. The story of them coming up in the garage, they're from engineers, they care about engineers. I can be an engineer my whole life and work there. Because I had decided back in college in the Vietnam days not to be political, not to ever go up a corporate ladder, just to be an engineer and design things. That was what I was going to do in life. And I could do that comfortably at Hewlett-Packard. Well, one time Steve came and said, hey, Nolan Bushnell of Atari wants another game built, and it was a game called Breakout. And I had to design it, and the job was to design it, but we only had 4 days, Steve said. When a game is made out of chips and it's not a program, 4 days is like impossible. This is months worth of work. And I said, okay. We were up 4 days and nights, nonstop, both got mononucleosis, and we got a Breakout delivered to Atari, and they paid for it, and that was a real fun experience. It was a little game with a ball that bounces against bricks. While I was in there working on it, and then Steve would breadboard my design for a little while, I would go play the first racing game that was going to come out, Grand Track 10. I got so good at it that eventually, when I lived in Scotts Valley, they had a pizza parlor, and if you got over 35 points on it, they'd give you a free pizza. After I got 2 free pizzas, they had to get rid of the game. So it was neat. And also, when I was in Atari working on this for 4 nights, working on Breakout, an idea came into my head, just who knows where, that if you spin data around at the speed of color TV, what comes out might look like color on a TV screen. Hard to say, but it was a little idea, because how do you put color on a TV? Normally it's a whole huge science of tons of parts and lots of analog loops and precision stuff, and I just had this little idea start then. Well, I went over to a friend's house one night, Captain Crunch. He wasn't a close friend, but every once in a while I wanted to meet him, because he would tell me a code. Once he told me a code to dial this and then a phone number in San Francisco, and you'll tap it. And I popped up tapping the FBI, listening to their sensitive conversations. And I was a little shocked. And he would point out that after 6 p.m. in a certain city on a payphone, if you dial 611, right when some machine cuts in, you start clicking out your own phone number and you can dial New York. And the phone company has a machine inside of their own phone company that they think dialed New York for some reason. So he was an interesting guy. You know what? There's a lot of accomplished, successful people in the world and CEOs of companies that I could go hang around, but I really, to this day, like to hang around those interesting ones. You know, usually a little out of control and wild, but they're always fanciful and entertaining. Well, I went over to Crunch's house, and he was typing on a teletype. Teletype's a machine, you go clunk, 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 like a keyboard. You type in English, and it types back to you, bump, 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 10 characters a second, real slow. You know, and these things cost a lot of money, but he was working for an engineer that had one. And he said, Steve, I'm talking to a computer in Boston. Now, there was this thing called the ARPANET that linked about 20 computers together. He said, now I can transfer to a computer in Texas, and they have a game there. And then I go over here, and they have some files that you can read if you're a guest. Whoa, this was like phone freaking again. It was like you can get around to all these computers around the country and the world. Oh my gosh, and all you have to do is dial a phone number and you're on. And that was just so amazing that now my next project, I had to design a terminal that put characters on my TV set, because the TV set was the only thing I could afford. I could not afford a $1,000 teletype, I'll show you. The keyboard, how do you get a keyboard? I looked in magazines, they were probably about $200, and I couldn't afford that, but $60 I found a keyboard, uppercase only, unfortunately for Apple's start. Uppercase only, $60, the most expensive thing I ever bought in all of the early Apple designs. And I did my design and got little shift registers that were the cheapest I could find and built this design with very few chips. And it was a terminal. I could call a phone number with a modem that I built and call a phone number at Stanford. And then I could get on my screen, it would print out things like lists of computers, and I could type in a number and get to a different computer, and then go on as a guest and see what it had offered, files to read for guests. And it was really interesting. I did it about 2 times, and from then on, all I did was talk about how I had done it, because the important thing was to do it. Who cares? I didn't have any use to use those computers, but it was sort of neat that they were spread out around the world like a big, huge network. And that was the start of the internet, of course. Well, Steve Jobs came along, he saw that terminal that I'd built, and he said, hey, let's sell it. So there was a local time-sharing company, and we actually sold a bunch to them. Now, my friend Alan Baum called up. I'd been designing calculators for 2 or 3 years. And this time I started a company. Very proud of it. It was the very first of its kind in the San Francisco Bay Area ever. Dial-A-Joke. The first Dial-A-Joke in the San Francisco Bay Area. Now that's a lot when back in the days when 1972, 1973, when you could not own a telephone or an answering machine. You could not purchase a telephone or an answering machine. You could only rent the one phone that the phone company gave you. The one answer machine they had for theaters was very expensive for an engineer like myself. Eventually, I ran 3 months behind on the phone bill and had to give up Dial-A-Joke a year or 2 later. But I started up the first Dial-A-Joke ever, and I'm so proud of that because humor's been a big part of my life. And I answered the machine would answer every call. Hello, thank you for dialing Dial-A-Joke. Today's joke is, and it would tell a Polish joke. And we'd hang up and, thank you. So hang up. And 2,000 calls a day would come into my Cupertino apartment on one-line number because I kept the jokes so short. 2,000 calls a day from little kids out of school and all day long they'd be pouring in. Anybody who had a phone number that was similar to Dial-A-Joke got 100 wrong numbers a day. Well, so this one lady was all upset because her husband worked nights and has to sleep in the day, so I changed the number. And then I found out a whole bunch of other people had the problem, so I told the phone company, I need an easy-to-dial number. And I finally managed to work with them. I asked for 255 in Cupertino, 255-5555. Couldn't get it. I got 255-6666 though. Oh, my first easy-to-dial number. Then I found out that the largest ski shop in Northern California, called Any Mountain, had 1 digit off, and they came to my apartment one day and said they didn't even want to answer their own phone. They were getting so many of my calls. So, but that was the first thing I started saying. I started finding out that if you talk to a manager in a phone company, there are ways to get neat phone numbers with repeating digits. And that was Dial-A-Joke. Well, Alan called me up, Alan Baum, and said, Steve, there's a kind of a group of people starting up an organization for people who have terminals and things. Okay? And he didn't say microprocessors. He didn't say the Altair computer, because if he had, I was so shy, I would have been afraid to go to the meeting. I would have been scared to go to something that I'm not really in on. I had drifted away from computers. I hadn't even known that microcomputers had come or what they were. I had drifted away designing calculators at Hewlett-Packard. So I had a terminal, and he said this was a club for people with terminals. So I took my terminal design, and I was willing to give anybody my great schematic and show how great a designer I was. And I got to the Homebrew Computer Club. It didn't have a name yet. The first night it started, about maybe 20, 30 of us in a garage. The garage door was open, it was night, it was raining outside. And there was a computer there, actually. And there were, Popular Electronics had a magazine cover with that computer on it, the Altair computer. Big square frame with all these binary switches, 0, 1, and lights, zeros and ones, and kind of techy, but A computer was there, and everybody was talking about it. Somebody had gone to their factory. Somebody else knew what they were coming out with next. Somebody heard of rumors. There were these kind of chips. There was that speed. There was another company going to start and make some peripheral for it. And I didn't know anything about it. So I was really scared. I didn't say much. At the club meeting, I did sign in. And when they passed out some data sheets for an 8008 microprocessor, I took one home. It was an Intel microprocessor. And at home, I studied it, and it had an instruction set. It had about 50 instructions. I said, wait a minute, these microprocessors are just like mini computers that I used to design in high school. I know this field. I know microprocessors. I know how to do this stuff. It's computers again. So I was back in business. I also now knew that I was going to someday have that computer that I told my dad I was going to have, because microprocessors from Intel only cost $400. Someday I could save enough money from my salary and I'd be able to pay the $400 and get one. Well, then I found out that I could get a better deal. Well, a company started up called MOS Technology with the 6502 microprocessor. They were going to sell it at a show in San Francisco where you come up with a $20 bill and you get a microprocessor. Okay, that was a cheap price, so cheap it was unbelievable. But more than that, microprocessors weren't sold. There was no store you could go to with any amount of money, $1,000, and buy a microprocessor. They didn't exist. You could go to a distributor, fill out a whole bunch of forms for your company and who the officers were and who were, the financial statements and all this stuff, and act like you're a company, and you could kind of get an account to order one. It was but there was no way to really buy one. So this was amazing. I went with my friends, paid $20 to Chuck Peddle, got the microprocessor, paid $5 for a manual, studied the manual and said, this is a neat machine. This is a great little microprocessor. It's missing a couple instructions, but it has some other advantages. So that was my microprocessor because I got it cheap. So now I got to build a computer. Went to Hewlett-Packard late at night after night after night till like 2 in the morning. And I'd go down to Denny's and have a hamburger. I'd work on my drafting table and put together the design of the microprocessor and some memory and my terminal. Well, the memory was the big aspect. All of the people that were building these little microcomputers, about 20 companies started up building microcomputers, the Altair and the IMSI and the processor technology ones and the Spheres. They all were using static memories called 2102s. Nice deal. You take a microprocessor chip and static memory and you just run the wires from the microprocessor to the memory, and it works. That's all there is to it. The trouble is, the static memory is costly. It takes more space on silicon chip than a dynamic memory. The first 4K dynamic RAMs were about to come out from 3 companies, 2 in Silicon Valley, 1 in Texas. Those were going to be the first RAMs of all time to finally be cheaper than core memories that all computers used. So this was going to be the switch to silicon for memory, but only with the dynamic memory. The dynamic memory had 4K on a chip. The static memory had 1K on a chip. 4-to-1 advantage. If you were going to have 4K bytes of RAM, it would take 32 chips of the static memories, but it only took me 8 chips with dynamic. My goal was to have fewest chips possible. So 8 chips, great. Problem with the dynamic memory is it forgets itself every 2,000th of a second. Every bit in it will be forgotten. So within that 2,000th of a second, you have to go in a whole bunch of times and eventually hit all of the bits with what they already have to keep them refreshed so they don't forget. So it's a little tricky. You have to kind of do a thing that reads them and rewrites them exactly as they are. Every single bit for a 2,000th of a second takes some parts. It takes some chips. It takes some logic. It takes some designing too. But I was an engineer. Heck, if I'm going to go from 32 RAM chips down to 8, I've saved 24 chips. So what if I have to add 5 more chips in to do some clever refreshing of the memory? So of course I went with dynamic RAMs. Why was the Apple, of all these little companies starting up, claiming, cheap little hobby computers, the Apple I was the first one to use dynamic RAMs? I still wonder to this day, weren't there any engineers out there building these things? I sat down and I looked at the Altair with its faceplate and all these other computers. They all had little switches. You dial in numbers and punch stuff. And theoretically, you could plug a card in someday to attach a teletype. and add some memory. They only came with 256 bytes of memory. So you add some memory and you'll have enough to run a programming language, but you aren't there with just the raw computer kit for $400. And I sat there and I said, that's just what I built 5 years before, called the cream soda computer. I'd been through that stage of switches and lights and so happy that I had a computer, but I wanted something useful like our calculators at Hewlett-Packard. Calculator has a human keyboard. You punch some numbers and things happen. And we have a microprocessor, really. You punch the 5 key and a program executes the right stuff for a 5 key, causes it to happen. You punch the plus key and the right thing happens for a plus key. That's all it was. So using that model, I said, rather than all these awful switches and all the wires to every switch and lights and all the circuits that have to get those switches and lights connected into the computer itself, and it was so awkward how many parts you would save if you didn't have the switches and lights, the binary switches and lights. I said, why don't I just take my keyboard from my terminal? Just use a keyboard. Matter of fact, I'll just take my terminal with a microprocessor, and now I'll write a little program so you start up and you type on the keyboard to cause the things to happen that you normally do with switches and lights. Let's move to something that looks like a typewriter, because it'll be easier for me to use. I wasn't thinking about the world. I wasn't thinking about selling these. And I designed it, built it, got my program working so that it could do in 250, I only had 256 bytes for a program, because you had to put the program in permanent memory. Permanent memory chips, these little proms of the day, the largest that were out were 256 by 4 bits. 2 chips made 256 bytes. So 2 chips was all I had to work with, and I got it to where you could type in some base 16 numbers into memory, examine memory and to your heart's delight, and tell a program to run some address. So it was still kind of icky and techy, but it was a lot easier to type than it was to use switches and lights. And besides which, if you ever ran a program like BASIC, you'd have to type on a keyboard. So the Apple took that big step of saying a keyboard comes with a small computer. It's a standard part of it. That had never been introduced by anyone else. I'm just amazed. Well, Steve Jobs came along and he saw that there were people around me at the club interested in this new thing. I was showing it off every week. I was passing out schematics. I was going down to people's houses on weekends and helping them solder it together. Okay? I mean, it was everything in the club, the Homebrew Computer Club. Lee Felsenstein would get up to introduce the meetings, and he would always say, the Homebrew Computer Club, which does not exist. And everyone would applaud, because we didn't want to belong to something that exists, you know, something that's real. And Randy Wigington was a high school kid that I met there. He came on, became one of the early Apple people. His job was to run a little chat system at the local company Call Computer every Tuesday night. Randy would keep it running. Well, I analyzed the BASIC program that it ran under, and what it did was it went to a file called chatx. One person could type at a time. One person would type into this chatx file, and then everybody else would read the chatx file for a while, and then randomly somebody else would get a turn to type. So what I did was I just wrote a program that waited until the chatx file was free, and then dumped 9 pages of Polish jokes into it. So week after week after week, Randy had to explain to the club why all they were getting was Polish jokes, and he didn't know. Funny thing is, while I ran my Dial-A-Joke, I took some calls live on Dial-A-Joke, and it was kind of neat because I was like the first chat rooms at AOL. I was anonymous. I was, hey, this is Stanley Zabrozuzkalitsky, I'm talking to you. Hello there. I actually met the woman, became my first wife. I didn't think I'd ever get married, but I actually was able to meet people this way. So that was fun. The Polish American Congress Incorporated threatened me with a lawsuit finally for defaming people of Polish descent and maligning them. And this was in 1974 or something. And I said, what do you mean? They're just jokes. And they said, sorry, you know, we're going to sue you. So I said, what if I change them to Italian jokes? And they said, that's fine. That was before political correctness. Now you have to be politically correct is more important than being correct. So anyway, on Dial-A-Joke, I forget. I know I was somewhere along the lines here. So Steve Jobs came along and said, let's sell this computer that you've designed. And, you know, because people were interested in it. And we figured out we'd make a PC board. And Steve said, we'll make it for $20 and sell it for $40. He was used to working in surplus stores. And I thought, with the money we're going to put out, we might put out $1,000 and we'd have to sell 50 computers to get our money back. I don't think we're going to get our money back. And Steve said, yeah, but we'll have the fun of having a company. Well, how could you turn that down when you're young, when you don't need the money anyway? We weren't doing it to make a money. You didn't have to justify being a company. You didn't have to justify it with a profit. So we decided to start the company. And then Steve would go up to Oregon and work with some hippies on a farm up there. And he would come back, and one time he came up with the name Apple Computer. How about Apple Computer? That's pretty good. We both tried to think of technical names that were more substance, and we couldn't. After a few minutes, we realized we weren't going to come up with something better than Apple. I was afraid it would be like Apple Records. I don't know where he came up with the idea, if it came from something. He might have worked on apple trees up in Oregon, but Steve doesn't really talk about other people he's had suggestions from, or where ideas came into his life, where they might have really come from. You don't get that picture. Many times later on in life, I found other people talking about what they had said to him, and I remember hearing him telling me like it was his own ideas. So it's hard to say where it came from, or if it had a source. It might have probably just came out of his head. So we had this little computer with dynamic RAMs, and Bill Gates had a BASIC that was circulating the clubs right around then that had just come out for that Altair computer. And people love to run BASIC. You read this paper tape into a teletype that's connected to your computer, and now you can enter games out of a book in BASIC programming language. And games are the fun thing in life. Well, I had never programmed in BASIC. But I looked around and I could tell BASIC was the language to go with. And I had my little 6502 computer, and I said, there's no BASIC for it. I'll write the first one, because I do things really fast. I've never had a course in writing computer languages. I had tried to practice on my own techniques to try to find a way to do it, but I'd never taken a course in it, never studied it, I had never done it for myself, for employers, anything. So that was a tough decision to decide to make a BASIC when I'd never even programmed in BASIC. I was a Fortran scientist type, ALGOL, some other languages. So I pulled out a Hewlett-Packard BASIC manual and started copying the grammar charts, the syntax tables, onto paper, deciding what elements I'd keep and what I'd get rid of. And really about the only thing major that I got rid of was floating point numbers with decimal points. Because I had two goals for this language. First of all, I wanted to be the first one to have a language for the 6502. I was real shy, but I love to be first at things in life. And to be first, I might save a few weeks if I don't have the floating point in. By the time we did the Apple I, I actually put floating point routines in the ROM. I could write them fine. That was nothing beyond me, but I left them out of this BASIC because I wanted it to play games and calculate logic solutions for my work at Hewlett-Packard. Two purposes, and you only need integers for that. Okay, I worked on this BASIC. I put in about 6 months of work. It was like a man years of work, day and night. It was much harder than designing the computer. But I wrote the BASIC, and it worked great. And every 2 weeks at the Homebrew Computer Club, I'd set up my Sears TV, snaked a cable out of it down to the little Apple I computer board, the little breadboard I had, and keyboard, and I would type for up to 40 minutes in hexadecimal, base 16, to enter the code of my BASIC into the machine. I never once raised my hand in a meeting of the 500 people in our Homebrew Computer Club, because I was too shy to ever talk, but I always sat in the back row because there was a power plug there. So I'd type this in, then we'd set up for our demo, and I would run BASIC and show people you can type this, and you can actually make some text on the screen, and you can type that and do this other things, and it can answer a question. And every week as I added, how could you think of products like the Apple I and the Apple II that were going to start a company, going to start an industry, having been so open as that, and just shared and shown off, and schematics and listings just passed out to anybody who wanted them. Pretty unusual. So in order to develop good products and start industries, you don't need secrecy. You only need secrecy, I guess, to protect your company from competition. And we didn't have any. The big companies came about. The Homebrew Computer Club was kind of neat. We'd have one session called the mapping session where people would raise their hand with rumors. People would say, I have some parts for sale. Other people would say, I'd like to get some things. Does anyone know how to do this with some kind of computer? And they would sort of spot who was needed what and who would offer what. And then we'd have the random access period. We'd all go into little groups and meet up with the people we wanted to talk to. And that was how the club was organized. Well, we decided to start this company and sell the Apple I, and we had a third partner, Ron Wayne. He was a real arch right-winger. He read books like None Dare Call It Treason, and he had golds in his mattresses and all this stuff. But he had been with a whole bunch of companies, and he'd always been screwed out of the stock options or something. He always got messed up. So we gave him 10% of Apple, and he wrote our legal documents right out of his head on a typewriter. He would type them perfectly with all the legal phrases, and he drew a big, beautiful etching of Newton under the apple tree for our first manual for Apple Computer, the Apple I, and he put the manual together. Well, I got a call at Hewlett-Packard one day. At first I told Steve, I said, hey, I work for Hewlett-Packard. Anything I design, they own first. That's my employee contract. So I really wanted Hewlett-Packard to do this. And I went to the lab manager and I said, you can build a machine that'll cost about $800 and you unplug it and you somehow run it up to your TV set on channel 3. And you type BASIC right away. And the lab manager liked it, but he had problems. Like if it's not a Hewlett-Packard TV, and there's a problem, who do you blame? It's how do you resolve it? And he said that, well, he didn't have the resources available. But for months after that, he kept running into me and saying he hadn't been able to sleep since he'd heard the idea of an $800 computer that could actually run a programming language. Well, Hewlett-Packard turned it down. So Steve and I went ahead and made our PC board. I sold my Hewlett-Packard calculator to get some money, sold it for $500. But I was an employee. The next month we were going to introduce the HP 67, and it was going to be $370 for an employee. So, not a big financial risk. Steve sold a van and got some money, and we paid somebody to lay out a PC board. And we were going to make PC boards for $20 and sell them for $40 and hope we get our money back. I got a call at Hewlett-Packard one day, and Steve said he's sitting down. And I said, yeah. And he said, I just got an order for $50,000. What? That was the biggest financial shock I ever got in all the running of Apple. $50,000? It's like, oh my gosh, this is big money. There was one computer store in our area, and they wanted to buy 100 computers for $500 each, completely built with all the parts. We were just going to sell $40 PC boards. Now we were selling $500 computer boards. Oh my God. Well, that was such a shock. And my supervisor said, you better contact HP's legal department. So I did, and the legal department of Hewlett-Packard spent about a week contacting every division of Hewlett-Packard to make sure they didn't want this kind of product so that I'd be, free to make it outside of HP. Fine. So I kept my job at HP, and we had Apple going. And Steve would get on the phone and call stores and find sales, and we started making the machine. Now, how do you get the money to make it? We had no money, so we had to get the parts. And to get the parts, Steve got credit. He went down to a distributor and arranged that we would get the parts and we could store them in a cabinet where the PC boards were being made. As soon as the PC boards came off the line, the closet got opened up, the parts got opened, and 30 days credit started. 30 days later, we'd have to pay for the parts. The same company that made the PC board would stuff the parts in the PC board and solder it together. So we didn't actually do any manufacturing in a garage or anything. The boards were all made for us. We just drove down and picked them up. And then we'd drive down and pick up some boards. Steve would drive them to the garage. We had one workbench in the garage, and I would sit with the oscilloscope and test the boards and find the chips that were pin bent under and shorted traces and fix them. And we'd put the good boards in white boxes, take them down to the dealer. We also arranged for the dealer to get cases and keyboards and transformers, the few extra parts it needed. So the dealer sold the whole thing as a almost built computer. And all the other products at that time were total kits. You had to do solder every single pin of every IC yourself. They were just total kits. And this one was the most built, the Apple I. And we had to come up with a price for it. The dealer would pay $500, so we made the retail price $667. And then I said, $666.66, repeating digits. So we got onto that. And it was kind of neat that finally there was a little computer. We looked at all the comparison charts, and our computer was always top of the list because they were in alphabetic order. But we had really best specs, and we had a good little Apple I computer. I started going around to a couple clubs of people and telling them what was on the board and how much they could buy for it and how they could do this. And there was just an interested type of person around for this kind of computer. But I sat down, I had designed the Apple I with a certain characteristic that I could add color to it by a method that I had thought of back at Atari. And when I started sitting down to say, hey, let me add the color in now, I'm going to try to add color into a computer by a method that's never been done, I started to come up with other ideas. Why don't I combine this? Why don't I combine that? Why don't I take all this logic and replace it with a shift register that just puts the signals out at the right time as though it were logic? And why don't I get rid of that and do this decoding all in one chip instead of having 5 chips in 8 places? And the whole thing came down to like half the number of chips of an Apple I, and yet it had, the first time ever in a small computer, it had color, it had graphics. The Apple II was the first one with high resolution, the first one with sound, the first one with paddles, the first one, the only one with dynamic memory besides our Apple I, and the only one that could put 48K of memory on one board, the motherboard. So it was way ahead of anything else. By the time we put it out, it was going to be the only one with a plastic case, the only one with a low temperature power supply, switching power supply too. So a lot of amazing firsts that really were going to stay with computers forever, but the major parts of it were that it was a fun computer from the technical point of view. We'll get to, there are 2 points of view as to why it's sold to people. But it had to be a little fun, a computer that invited you to say, I'm not afraid of this machine, I can learn how to program it. Okay, the computer as delivered was the first time ever 2K ROMs were used in a product. The Apple II was the first product ever to use 2K ROMs, and it was the first product ever to come with a language running in ROM. Turn a computer on, turn it on, click, and it's running BASIC. Such a thing had never been conceived of before. Before, you turn a computer on, you toggle some switches or something, you do some funny stuff, and eventually you get to load in BASIC off of a paper tape, and then you can run it. So it was really cutting to the chase of what you wanted to do yourself. You wanted to program a solution to some problem. Maybe the problem was a math puzzle. Maybe it was you wanted to enter a game out of a book. And the Apple II was just great for that. So far ahead of all the others. The trouble is, how were we going to build it? In the meantime, the Apple I was the first computer that had the keyboard and said a computer looks like a typewriter. Processor technology introduced the Sol computer. It came with a keyboard and a little black and white display. And now it was the hot seller. It was selling 1,000 computers a month. Its stores were springing up in cities around the country. And now we had the Apple II that was 10 times better than anything else. It was going to sell at least 1,000 a month. That's a huge number for starting a business. And the trouble is, how do you build 1,000 computers when they cost $250 each to build? You need $250,000. We went to Commodore. We showed them our Apple II. We went to them. And they finally, Jack Tramiel finally decided, no, we're going to do our own computer. They did a real cheap one. You know, it had black and white only, and it didn't have real graphics like we had, and it didn't have high resolution, and it had a crappy keyboard, and it didn't work with your home TV, and it didn't have sound and paddles and all that, and it didn't have RAM, and it didn't have expandability. So they built a cheap computer called the PET, and Radio Shack came out with a little pre-built computer also. We took our Apple II design to Al Alcorn's house of Atari. And he loved it. He loved it. But Atari was about to come out with the first Pong game for home, the first home video game of all time. And they had their hands full with huge success, huge business success. They didn't have enough room and time to take on another project like our Apple computer. And we didn't have money to do it. Venture capitalists came to the garage and asked questions like, what's the market size? And I don't know business talk. I didn't go to business school. I just said, there's 1 million computers at least. He said, why do you say that? I said, because there's 1 million ham radio operators and computers are bigger than ham radio now. So it wasn't the right words for a venture capitalist, but he got Steve Jobs in touch with Mike Markkula, who lived in the Cupertino Hills. Mike had retired from Intel at the young age, I think like 32, well, because he had a stock option, and made $1.5 million, and he had a nice home, and he had a family, and he invested money, and he followed computers. He followed electronics. And he really did believe in computers in the home someday. And he and Steve started talking about people and in the home and normal things and how we were going to make the big step to getting computers in the home was not to make them affordable, was not to make them necessarily technically available. It was to make them palatable to people, something a person would be willing to put in a home. And they foresaw that this market was going to be gigantic. Mike Markkula predicted that in 5 years we'd be a $500 million company. All the big computer companies, IBM, Intel, Varian, Hewlett-Packard, they all said, poo-poo, it's just going to come and go, a little garage thing, it's not important. When we were at the Homebrew Computer Club, we had to just stand up and feel we were at a revolution, and we were standing up against what big business were saying. Everyone was going to have a computer in their homes, what we believed. And Mike Markkula believed this, and he had money. Well, he decided to invest $250,000 in Apple, and he became an equal partner to Steve and I. He had just as much from the start. And Mike said that I had to leave Hewlett-Packard. And for me, that was just so hard. And I went into my own mind, and I thought about what I like to do in life. I like to design computers, and I like to write software, and I like to show them off and do things with them. But you know what? I don't run companies, because I wasn't going to be political and do the things you have to do to run companies, and I would just be, all these stories of executives getting kicked out, I would just be trampled on, and I decided not to start Apple. I went to the ultimatum meeting on the ultimatum date, and I told Steve and Mike Markkula, I'm not going to do it. I'm not going to do this. And Steve went into a frenzy, and he wanted this Apple II, and he got my friends and relatives to call me and say, Steve, you've got to do this. You're going to have money coming in and all this. And finally, my friend Alan Baum called, and he said, Steve, you can start a company and be an engineer and become a manager and get rich. Or you can start this company and be an engineer and stay an engineer and get rich. And it was when he said that I had the right to stay an engineer and still make money off my design, I needed one other person saying that I knew that I had a stable base to say, as long as I'm the engineer, I deserve it. And then I went and started Apple, left Hewlett-Packard that day. But it was not easy coming to that for me. Hewlett-Packard, around this time, started another microprocessor project also before I left. They started one right in our lab, and it had a microprocessor, and it had dynamic memory, and it had 5 people working on a BASIC, and people on printer interfaces, and people on cassette tapes. I had just done all this stuff for the Apple I and the Apple II. And I went to the boss, and I said, I don't want to work on calculators. Computers are my life. I want to be on this Capricorn project here in Hewlett-Packard. And they talked to me, and they turned me down. So I got turned down from what I wanted to do, work on computers in Hewlett-Packard. Second turn down there. I had a third turn down too, in another division. So I tried. Well, Steve and I, when we started Apple, now we had the money and we built our first 1,000. One of the things was to build a plastic case, and there was a guy over in Palo Alto that had a foam process like they make motorcycle seats out of that could make plastic cases sort of affordable. He could make about 5 a day or 10 a day. It was we could barely get these cases made, but thank God, in the meantime, we got some money, and we put some money into making a real good quality ABS plastic case offshore, and we had to survive for about 6 months. And when we finally got that case coming, we could crank those computers out. And the Apple II was selling really well, because all the stores that were starting up around the country was brand new business, empty shelves. Hey, Apple's the best product going. They all wanted some Apple stuff. We had a great introduction of the Apple II computer. We had great advertising. We had the best product by far and the most built one. So they just bought it, and we didn't have to fight for shelf space that somebody else already had. The stores were all new. It was just so rare. And in the company, we all felt like we were on top of a revolution as we grew towards 10, 20, then 40 people. It's a revolution. Nobody left the company. We're the leader. We're doing these great things. It was so exciting. Every day was exciting, just being around Apple IIs. Answering the phone, a lot of people remembered that, heck, for those first couple of years, I answered the phone myself a lot of times and answered their technical questions. We needed a president as soon as we started the company, and we talked to Mike Scott, who ran a division at National, and he came in. He was just hard, kind of no-nonsense type guy. He could joke, but he could sure spot, what wasn't going right and make sure it got turned around and got done right. Steve Jobs is a lot like that now. You need that when you run a company. You need somebody that just will address the right things, even get rid of the right people if they have to be. we had another engineer that designed a neat switching power supply. He had engineering talents that I didn't have. I was good at computer stuff, and he was good at power supply type stuff and signals and TVs and things, filters and that sort of thing. So Rod Holt joined us, and he offered the other side of engineering. He liked to learn a little computers, and I learned a little from his designs. And so Mike Scott, the president, for up until the time we went public, you almost never hear of him anymore, but he had a pretty important role in history. Rod Holt, the other engineer, myself, Steve Jobs, and Mike Markkula ran our marketing, which was his talent. And that was the five of us that ran the company for the first 2 years. Randy Wigington and Chris Espinoza were two high school kids that I met at the Homebrew Computer Club, and they were so interested. Heck, Mike Markkula, myself, Steve Jobs, we all went to Randy Wigington's high school graduation even. So, and they were very instrumental in some of the early software, early projects we had going on. Mike Markkula had personal ideas about the sort of software that you had to sell to people in the home. It had to be home-like things. It couldn't be mathematical computations, database storage. It had to be recipes, or it had to be run your checkbook. Well, the checkbook was a little bit of a problem. It was an important program, and Mike wrote a lot of it, and Randy helped him a bit, and I did little parts of it. But you had to read in the program on a cassette tape to the first Apple II. Once the program came in, beep, you had to read in the checkbook data. And then after it came in, beep, you'd be waiting, 10 seconds for the checkbook data. Then you could modify a check or two and write the checkbook data back out. Beep. It took forever to do anything. It was so slow. So at one of our staff meetings one day, Mike Markkula was writing down the things we had to work on soon. I had been working on things like printer interfaces and serial interfaces. And our interfaces on the Apple II were really neat. You plugged a little card into the computer that attached to the cable to your device. But the card had the driver for the device. So it was really plug and play. You plug it in, you don't have to install anything ever. The installation came right on the card that you installed. Why don't they have printers to this day that just have the driver inside of the printer in a ROM? Or a certain kind of disk drive. Just put, if the driver were in there, you could even flash it up to date, and you would never have to keep in your computer in the operating system, with all these extension problems going bad and all. So I wish we'd go back to that kind of plug and play. Well, Mike Markkula said we needed two important things. We needed a floppy disk drive for speed, and we needed a floating point BASIC to handle checkbook floating point numbers. And I started working on the floating point BASIC, but it was a real new exotic BASIC. And before we got too far into it, Microsoft came in the door and said they had a BASIC. I know they didn't write it themselves. They just bought it from some guy. But I was that's okay. We were off the hook for that. Their BASIC was fine. We got them to adapt a few things to add commands in it to draw colors on the Apple screen. And then the floppy disk. I'd had this little idea before leaving Hewlett-Packard based on a new chip that came out, a little 8-bit shift register. So I had a little idea that would control the shift register to get bits coming off a tape, one bit at a time. Click, 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 click. Highs and lows coming off the floppy disk, just like it was coming off of a tape machine. And another little machine would somehow cycle things by making decisions, and the shortest little decision maker was called a state machine, a little register that was like an address and a little ROM that made decisions. And took all the little signals in that it needed. And I thought, oh man, I could go to Las Vegas. I said, can I go to Las Vegas if I get a floppy disk going? And Mike Markkula said, yeah. And I was so naive back then, that's how I worked. So I thought, my goal is, I've got to finish the floppy disk in 2 weeks over Christmas vacation. Working Christmas Day, working New Year's Day, got Randy Wigington to work with me all those days. I got to design a floppy disk and so we can take it to the show. And I set about and I built in this little thing that could read and write data on a floppy disk, but I never knew how floppy disks worked. I'd never seen a controller before. I'd never studied it. I didn't know how they were built. And when I was done, I had 5 chips could read and write. Our final one that we shipped came out to 8 chips. I had 5 chips working, and the competition had like 50 chips or 35. So I pulled up their manual. I pulled up a board that we had bought once and pulled out a manual, and I started going through their schematic, figuring out what all their gates did. And when I got done, I realized that mine did a lot more. And not only was mine 5 chips instead of 35, but I bypassed about another 10 chips on the Shugart disk drive that weren't needed. Why not put the data out in a more direct format? So we had a real hot product going. Randy wrote some of the software, I wrote some of the software, we got our demo going. We went to Las Vegas. walking down, seeing those lights down the street, those big flashing lights. Randy was still 17, but he made some money anyway. Because you'd have to pass the casinos, walk into the convention center. And we went to the convention center and worked all night on the last demo floppy disk we were going to make. Well, the first one. We were finally going to finish everything, and we wrote track 1. You'd have to put one disk in and read track 1, and then another disk in and write it onto that one to make a copy. Read it and write it, read it and write it. We got the final thing working at 6 in the morning, and we copied the whole disk. And then when I was done, I was looking, which one was the good one to start with? It turned out we'd copied like an old blank disk or something onto the new good one. So I had to go back and sleep a little, and then we fixed it up. We showed it at the show, and that was the start of Apple's floppy. A neat thing happened. In all of the designs at Apple, I did everything. I designed computers. I designed cassette interfaces. I wrote the software, the mini operating system software of Apple IIs. I wrote graphics software. I wrote computer language. I designed a floppy disk. Whatever was needed, I was my own technician. I always built them myself, soldered every wire, tested them with the oscilloscope, made notations, did the code. I don't know how I just did it all. It was a rare point in time that one person could just do all these little tasks. Multidisciplinary is what it's called. Now Apple kind of grew up and had gotten to the point that one person would design something, one person would conceive of it, a manager. Another person would design it, kind of. Another person would draft it, and another person would be the technician to build it, and then the engineer would usually come into the lab to test it, or they had testers that would test it, and then another company would make a PC board for it. And it's like, we weren't that big yet. We'd only been around for a little over a year. But we had all these little categories of jobs. But I went and I said, well, who does our PC boards for the floppy disk? And somebody said, oh, well, they're busy right now. They're doing some other board. And I said, oh, good. So I went in late at night for 2 weeks in a row and laid out this big piece of Mylar and bought some tape and learned how to tape up all the traces on the floppy disk board so I could position the chips real tightly and small the way I like things, and I could make sure that there weren't a ton of holes through the board, which is the cheap way to do things fast. And when I was getting near the end of my job, I would say the last technicians would go home about 2 in the morning. I'd stay till 3 or 4 usually. I got to the end of my job and I spotted that I had 8 little holes in the board. And I figured out that, wait a minute, if I had that shift register going the other way, I would save these. I'd only have 5 holes going through the board to get traces from the top to the bottom. So I went back to the schematic, changed the schematic, reversed everything, had gates going to different pins, went over to the layout, to the circuit board that I was laying out, the PC board, and redid it, and it only had 5 holes going through. It's kind of an art thing. No user would ever see that. But somehow I would know that it had been done the right way, that if 2 people came down with the same goal, make it as minimal as you can, I was now closer to what they'd wind up with. Any people from anywhere, an alien came, they'd come up with the same thing. There's a principle called Occam's razor. If you have 2 different approaches, take the one that's simpler is probably right. And the other rule that I use is if random people you were going to invent a logical system like time on a clock or dates on a calendar, the logical system would be one that anybody from different countries and cultures and even aliens would all come up with. Is probably the most logical based on nature. Probably wouldn't be base 10 for our numbers either. So a program came out called VisiCalc, the first spreadsheet. Showed up kind of surprisingly, and here it was, and we discovered right away people could buy an Apple II computer. VisiCalc could run on an Apple II computer only. There were 3 computers being sold to the public, 3 real personal computers. Radio Shack TRS-80, the Commodore PET, and the Apple II. Those other 2 computers had no expandability, no way to add RAM. If you bought it with 4K of RAM, you were stuck with 4K or maybe 8K. And there was no way to add a floppy disk. There was no way to add peripherals and all these neat things. They were stuck. They had to go back to the drawing boards and waste 1.5 years coming out with the right product. So VisiCalc could only be written for the Apple II because it was the only one that had 16 megabytes, 16K of RAM. Sorry, K. So we could support 16K RAM. We could actually have up to 48K on our main board. And you could plug other boards in for floppy disks or more RAM or anything you wanted. So it was that expandability that really made Apple the winner in this whole personal computer startup. Because people would go into a store and they could buy VisiCalc and an Apple II. Hardware and software. Hardware and software. Solution. The package is a solution. All somebody wants is a solution to their problems. They don't care what the hardware is. They don't care what the processor is. They don't care this. They really want something that can run some good software. And that's what really put Apple on the map. And within a year, we were going to, be going public. We had so many shareholders. When we went public, around that time before we went public, well, I had a chance to get a house, which was something I always wanted in my life, by selling some stock to an investor. And I thought, well, this guy's just a fat cat with a ton of money. Why would I want to sell it to him? And he's going to get rich off Apple going public. So I decided instead I would take employees of the company that were in engineering and marketing, and each one could buy 2,000 shares of my stock. So I'll get my house, but then everybody inside the company gets to benefit. And I took other people that never got any stock at all at Apple, but they were around telling jokes with us. They were doing jokes. They were helping write a little program. They weren't the big stockholders, but they kind of deserved it. I wouldn't have done whatever I did if I didn't have friends to be around doing it with. So I just gave them stock outright. And because I never started this company to have stock, to have money. So to me, it wasn't really some big deal to part with. You got to keep the most you can have and turn it into even more. Never thought that way. So this WOZ plan where I sold all the stock to employees really scared our lawyers because we weren't even public yet. And they finally okayed it, but I'm sure it has never been done in other companies, what I did exactly. It was really hairy. So the Apple III, now we started getting, Steve Jobs was always very paranoid that competition was right around the corner and there were big companies, big companies like IBM and Hewlett-Packard, and they were just going to stomp on us. But no, Mike Markkula said, they just have people like we do. They have little teams, groups that are designing products. And well, once VisiCalc started selling, we decided the market wasn't for people with Apple IIs. It wasn't for people playing games. It was for business. So we designed the Apple III. It was sort of conceived of in the upper levels of the company, by the executives of the company. And what the machine that people were buying was what we were going to build, real precisely. And it would only have 2 slots in it. And it's kind of funny because the only argument Steve and I ever had over the Apple II is he said, it should only have 2 slots, one for a printer, one for a modem. And I said, no, you want lots of slots for computers. I want 8 slots. And besides, I had a clever design that got 8 slots for free. And he said, no, it's got to be 2. So I said, well, then get another computer. So that was an easy solution. But the Apple III only had 2 slots. It had a lot of other problems. But to sell the computer, you had to make it Apple II compatible. Because the Apple II was selling gung-ho everywhere around. Companies were starting up and putting out cassette tapes and floppy disks of games, and it was a big seller and a big success. So we built an Apple II mode in. You flip the switch one way, and it boots up as an Apple II. Flip the switch the other way, it boots up as an Apple III. And this is a rare thing you'll ever hear in your life. We in engineering got told by marketing we had to put in extra chips to deliberately disable functionality in the Apple II mode, to make it so that it wouldn't use the extra memory and wouldn't use the 80 columns of characters mode. We had to actually put in chips to make it weaker, so that people in their head would get a better idea that the Apple III was for work and the Apple II was for games. And that was pretty misguided thinking. The Apple III had a lot of flaws. It had hardware problems. It had the only piece of software that came out with it was VisiCalc because Apple didn't write that one. Everyone we were working on didn't come out with it. Had horrible hardware problems with traces too small and shorting and breaking and dealers complaining and no Apple IIIs would work. So it just basically didn't take off. A year later, we fixed it and we got the clock in that was supposed to be in it. But you can't fix a problem when it gets psychologically in people's minds as a miss, that it misses the market. You can't come back and fix the problems and sell it. Maybe you could redesign it, change the shape, change the name to Apple IV, maybe it would have sold. So the Apple III never took off. Around that time, I was traveling around to a lot of computer clubs and talking to them, telling them the stories like I'm telling today and what we were up to. And I noticed that everywhere I went, there were a couple people in the audience with Apple IIIs, but everybody had Apple IIs, and all the questions were Apple IIs and this software and that one, and do you have this, and here's this new one, why don't you try this out, Woz, and everything, the whole world was Apple II. And when I went back to the company and walked in the door, I'd be met by people like Mike Markkula, and they'd say, have you heard about, well, first of all, everyone in the company had an Apple III on their desk. They didn't have Apple IIs. And they'd start talking about, we got this project coming out on the Apple III, and we got this software thing going on the Apple III. Everybody was working for the Apple III. There were almost no Apple II projects allowed, 1980 to 1983. The world didn't know that. The world was going crazy. Apple II was the largest selling computer in the world each of those years, 80 to 83. Apple had full-page advertisements every month in national magazines. We were so successful. Go back in those 3 years and you'll find out that not a single ad showed an Apple II. They all showed Apple IIIs. It's like there was a real world and there was this inside the company was lost. They didn't know what the real world was doing. Thank God. Thank God Apple didn't muddle with the Apple II, changing versions, making things incompatible. It lasted for so long, and all these outside companies were putting out games and advertising this for the Apple II, and this little hardware for the Apple II, and this display board for the Apple II, and this interface board for the Apple II, and this MIDI board. So everybody in the world was advertising Apple IIs except Apple. And it was just the largest selling computer in the world for 3 years. Apple has this history of, to this day, of taking the big product that's the bread and butter of the company and not putting all the support and letting engineering have money and keeping it supported well and introducing new products as a lightweight and let them grow and give lightweight effort. Apple tends to do it the opposite. Kill the bread and butter project and try to almost forget it, almost no projects at all, and all the emphasis goes on the new. So all the work goes on the new stuff. And that happened later too with Apple II and Macintosh later on. Eventually, there was a guy that joined our company in the Apple II time frame before the Apple III named Jeff Raskin. And he was a concert pianist. He had been a professor of music at colleges like Stanford. Real bright guy. And he sat down with Steve and I in the earliest days and explained that when you have something, you should look at it and make it simple so that people understand it. You should write a manual, and write a manual so that it is simpler to write the manual. The product is then better. He even said this about the Apple II. And the manual has to be very clear. But you should take a child or somebody that has never ever seen what you're making. And you should have that person try to use it and watch them and see where they have troubles. And you should not take an expert that does know how to use it and look at them, because you'll never get valid information. Look at somebody that doesn't know how and make it so they can use it. And Jeff was a believer in this, and his thinking really influenced me a lot to believe that these are the right dreams, that computers should be designed to be just work the way people do. Humans should come first. There was a period of time with the Apple II when you bought a computer and you ran a program or you wrote a program, but you were the master of that machine. And nowadays it's like we're the slaves, because you kind of buy programs that other people wrote and you just have to learn where their menus are and how they work and what order it is and keep them up to date and fight them like that. And so we lost a lot of that, the idea that a lot of smart people in Apple were really trying to do, which was really to give people more power in their life themselves rather than just buying something else of someone else's. I had a plane crash and it was really lucky. It started the Macintosh project. I was working on it for Jeff Raskin and others and coming up with a processor design. And I had a plane crash, and it was so lucky because I realized that I had 3 years of college done and I was a good student. And why don't I go back and get my college degree? Because by now I was going to get married. I was going to have children, and I wanted to tell my children, that school is important. So having a college degree was good. So of all these computer noted people that you hear about, I'm about the only one that did go back and get a degree, finished off. And I never dropped out. A dropout says college is worthless, like Larry Ellison, or they flunk out. And I wasn't in those categories. So thank God I got back and managed to finish and get a real college degree from Berkeley. Went back under a fake name. So I was pretty well known by now, but not by my picture. So I used the name Rocky Raccoon Clark. And of course, after doing something so imaginative, I had to get the degree in that name. So I got the degree in that name. And the last day of finals, Steve Jobs and I had our pictures on the front of Time magazine. So I wouldn't have squeaked by another day, but I made it through that year. When I went back to Apple, I put on some rock concerts and went back to Apple to work in engineering on the Apple II, where I could contribute the most. And I went to the Apple II division and found out that it had been smushed to nothing, but John Sculley joined the same day I went back, just about. It was a funny thing. There was a day that we were supposed to announce John Sculley we were supposed to announce who the new president of Apple was going to be. And another friend of mine, Dan Cochran, well, there was a guy, Jerry Brown, that wanted to visit the campus that day. And Steve Jobs brought him in, and he told Dan Cochran, take him around, show him the Lisa, and show him some of this other stuff we're doing. So he took Jerry Brown, didn't quite understand the Lisa, and he was walking around with him, and everybody looked at him and thought it was the new president of Apple was Moonbeam Brown. There were resumes flying. A little joke. But John Scully came in, had a meeting right away on a retreat, and basically decided right away the company should be reordered. And instead of being 95% Apple III, which wasn't selling, it should be 95% Apple II, which was selling. And, rearrange things in that way. Sometimes you just have to acknowledge what the truth is. And you have to be part of the real world. To this day, I do a lot of that just by, I won't take a computer from Apple. I won't take any repairs from Apple. I won't get any special assistance from inside. I won't pull any strings because I want to know what real people go through buying it at a normal store, and what problems do they have, and what's available and what's not, and what works, and when can you get answers on the phone? When does it take 40 minutes to get them, and when do things get fixed and not fixed, and what do they tell you? I want to just know the part of, be real. It's like reality TV almost. And I did leave Apple another time, but I never left it permanently. I was always so loyal. I was always on the payroll because I wanted my name in the computer that tracks how many years have you worked for the company. So I've never been without a small salary ever since. Well, actually, when I went back to work in the Apple II division, we started a project called the Apple IIX, and I helped inspire that, and it got killed because it was only going to sell 2,000 a month, and the 2GS came out of it from the people that had been in that group. But I started getting all these phone calls and travel and press and interviews and so much, and I take all my phone calls myself. I didn't have a secretary. Your phone wouldn't ring because that's not my way in life. It's reality. And I got so busy that I couldn't do the engineering work. I start some directions, but I couldn't really do it myself. The other engineers were doing it. So I had my boss cut my salary below theirs because engineers deserve higher level salary than somebody who's just, a company celebrity. But I keep a low, but to this day, I've been on the Apple payroll, so I'm in the computer the longest. They put me on a stage once and said, we're going to give you this new 20th anniversary Mac and a 20-year pin. Man, I wanted the pin. I didn't, I'll buy it back maybe. I wanted that 20-year pin. I still have never got it. They forgot. I sent Steve Jobs a letter about a year later, and I said, did you ever get your 20th anniversary Mac? We were supposed to both get them. And it came. I'm going to answer questions about current stuff. Steve Jobs and I are still in communication and friends, and a lot of just what's going now. Products, you'll find that I can answer questions on. I didn't give a speech on that. Macintosh, where it is now, where it's going, everything's open. So thank you very much for listening to